Deborsi obviously also has been a very active contributor in many aspects of IEEE, even future network. And so he'll be talking about resource allocation, service provisioning for softwarized network slicing using game theory. This is another interesting area. And briefly introducing Deborsi, he's a research scholar at Indian Institute of Technology, Kharagpur, specializing in network science, scientific research within communication network lab, Department of Electronics, Electrical Engineering. He holds MTech in communication engineering and BTech electronics communication engineering from IIT Kharagpur. He's been an active member of several professional organizations like IEEE, IEEE SA, SIGCOM, SM, Sigma, iMobile. Okay, I'm a member of SIGMobile. Okay. And Internet Society. He also serves as an IEEE Computer Society student ambassador, IEEE branch ambassador, and student coordinator for IEEE collaborator. Oh yeah, that's great. He's a life fellow of the Institute of Organized Research in India. Excellent. So I know there was a thanks for all your contribution. Let's see what you have, and then we can figure out some focus plan for your presentation, next steps. You got 20 minutes plus 5 minutes we can discuss. Thank you. Please proceed.
Yeah, so thank you very much. So let me quickly share my screen.
Yeah, please share your PowerPoint. I know it's pretty late up there, so. It's close to midnight, right? All right.
So I guess it's visible.
Yes,
Yeah.
please proceed.
Yeah. So thank you very much, Dr. Ashutosh sir, for the kind introduction and also for the kind invitation. So today I'm going to present my work titled Resource Allocation and Service Provisioning for Softwarized Network Slicing using Game Theory, a Techno-economic approach. So a very good morning, good evening, or good afternoon, depending on whether you are joining me today. So my name is Deborsi Basu, and I'm a scientific researcher at Communication Networks Lab at IIT Kharagpur. And very recently, we just ended one part of this work, which are currently under review on various international conferences. So I was just thinking to present the work this summit. So for any further contribution. So these are some of the contents that I'll be looking into. So very briefly, we'll see what the softwarized network slicing means and how various resource allocation challenges are there. Then a very brief literature survey, and then we'll see some of the open scopes. And then the techno-economic deployment for the future networks, and we'll see one of the test cases along with some of the results, and also we'll conclude with some open future research direction. So as we all know that this softwarization and network virtualization enables the network slicing technique, which is nothing but the concept within the modern telecommunication networks that enable us to virtually or logically slice or distribute the physical or shared network resources among various entities or the users, or that might be kind of network operators as well. So the main challenge, as we know that due to the evolution of this network slicing technologies, are like as because it works on the shared medium, so things becomes extremely complicated and challenging when we would like to distribute or like to utilize the resources that can be in the means of the network bandwidth or the spectrum or maybe various network physical resources that can be resources like the energy and other related hardware or software resources among various entities. So that may be in the form of various end users, or that can be the network operators. So things become extremely challenging as because the things are shared, but at which time at which part of the resource should be utilized by which entity is something very much complex. So, and there is no particular or fixed framework that actually can do this kind of stuffs. So, like, just briefly tell about various recent research works that we see that some of the research works that have been done by researchers, mostly the cases like use cases in the network slicing, in the consideration of the RAN sharing, as well as the end-to-end orchestrations. There are certain limitations due to the resource purchasing and sharing problems. That's because you know that the multiple network operators, when they actually uh, build their own network distribution strategies to obviously provide services, like different tenants or the network operators has their different individual service agreements. Like they obviously would like to do the business in such a way that they can get the most benefit, and also they can serve the users and their users as per the requirement. So three major players who basically dominate this sector, right? In between which the resources are being exchanged. So the primary one is the mobile infrastructure provider, right? So the mobile infrastructure provider who actually provides the backend infrastructure. So that that may be in the form of the network hardware or maybe in the form of network software. So just for an example, like the mobile base stations. So nowadays, or with the softwarization of the network, which will be in software-defined base station. So like the mobile infrastructure provider mainly built and manufacture those materials, and that is actively used by the intermediate entity, which is known as the mobile virtual network operators or the MVNO. Right? So this MVNOs actually utilizes the resources that has been provided by the MIPs, and they provide services to the user entities, like those are the end users. So some of the KPIs or the some of the different services of 5G or beyond 5G networks are, as we know, that URLs, EC, and EMB defined data rates or defined bandwidth these individual services and applications actually uses. And obviously, depending on whichever applications one user is availing, depending on that, the MVNO, associated MVNO actually provides the services. So, in a very simple way, if one needs to understand that how these services and the resources are being flowed uh, from one entity to another. So just for an example, that if we have the MIPs, which actually provides various sliced resources, just like spectrum or the switches or the base stations, and MVNOs basically may take or lease or sometimes rent, take those entities as in form of rent, and they further virtualize or logically do different operations on it to provide the required services to the end users who are actually connected with those infrastructure and being mainly operated by the MVNO. So some of the examples in Indian perspective, you know, the Reliance Jio, Bharti Airtel, and Vodafone, and like in international, there are some other like MNTL and other big telco operators are there who are actually working in various other countries, and so the main objective here is to make a suitable balance, right? And we remember that when we actually started this work, so that time, like in India specifically, as because I'm like right now here, so here we see that the inappropriate or abrupt changes in the mobile tariff plans, right? So it is difficult to for any users to select a particular plan in which one user can get the most of the benefit, right? So why this is because the tariff plans, the mobile phones are designed in such a way that uh, like most of it is not satisfying the user demands, right? Sometimes the cost is too high that it is very difficult to avail for any common user. So that actually motivates us to bring some of the ideas or to bring the some of the resource allocation schemes so that some way or the other we can, like, is it possible to make the exchange of this resource phenomena more cheaper, right? So to somehow if we can make this cost less as possible, so that most of the users can utilize the benefit of the modern telecommunication revolution. So some of the very basic challenges are already here. Mostly in this work, we will be mostly focusing on the economic challenge, right? So whenever there we see that the population density is less, so in those areas it is difficult to encourage the mobile network operators to come and invest for the new infrastructure, as because they know that the return on investment is not going to be that high. So suitable network frameworks as well as the algorithms of the resource allocations are required, so that it can as satisfy the end users, as well as it can also encourage the mobile network operators to bring new features in those domains, right? So the motivation is simple and clear, is that like we'd like to encourage the telecommunication service players, mainly the virtual network operators or the service providers, so that they can come and deploy the services to the mostly the rural or remote areas, so that most of the people residing there can have the services or the additional services like the 5G or the future upcoming 6G uh, will be adding in the telecommunication department. And also, like would like to model such system as is a challenging task, as because there is no standard solution is there, and it is very difficult to frame a particular service level agreement, because due to diverse user demand, as well as the different types of network operators are operating inside the telco market. So we'll demonstrate a theoretical analysis what we have done using this framework. So basically, we have taken one scenario in such a way that we have considered some users, like around like 100 users are distributed in the 1,000 by 1,000 disk cross grid region, where various users are enjoying different types of services like URLs, TMPP, and MMPC. And the channel model and the backend contributions has been followed by using some of the standard model. So these are the some of the simulation parameters that we have considered. We considered here that 5 different base stations which have been covered or basically managed by different or like 5 MIPs in this case, and we have a random distribution of the users between 1 to 100, and there are several SLAs and SLAs depending on the EMBB, MMPC, and URLC users, which we who are actually enjoying different services. We have kept some band range here, and also the other parameters has been taken care of. So the MILP formulation has been done in 3 categories. One is for the UEs, another is for MVNOs, and the third one is for the MIPs. So the very basic task for a UE perspective is that a user would like to avail a service with the minimum cost, right? So here, this shy parameter is the cost parameter function. So X is the binary variable. So if a particular user is availing a particular service, so uh, and the cost of the service is defined by Shai. So basically, we would like to minimize this, providing the user would like to avail a particular service with minimum cost. And one particular user should be connected at least at a time to a single MVNO. So as we know that, for example, at a time, one user can avail service from a particular mobile network operator. Maybe that can be Reliance Jio or Airtel or Vodafone, like those who are using the Indian perspective or Indian SIM or services. And the MVNOs basically are the middle player, actually, those who are trying to provide services to the users and taking the in or using the infrastructure from the mobile infrastructure provider. So what they would like to do is that they would also like to maximize their profit, right? So whatever the margin they are achieving, like so they're investing for getting the service from the MIPs, and also they are getting the revenue from the users, as because they are selling the resources to the users. And obviously the boundary conditions are set in such a way that we have assumed that there are certain upper and lower limits of the price being offered by the MVNOs, as because like it's not suitable for any market scenario that there should not be any upper limit for that. So for the sake of the users perspective, so that the user can avail those services, we have kept some upper and lower bound for the MVNO's price limit, and also the MVNOs having the resource restriction boundary. So the total amount of resources that are being demanded by all the users served by the MVNO should be less than the total amount of the should be less than the total amount of resources availed by the particular MVNO. Similarly, the MIP's job is to maximize the revenue. So here is the main objective, right? So we are keen to maximize the revenue of the MVNOs, MIPs, so that they we can make them more benefited, and also this can encourage them to bring new services or additional features for the next generation communication networks. And similarly, we have a price lower bound for the MVNOs, as because we also would like to give a fairness to the MIPs and MVNOs as well, just like the users. And here the total profit or the revenue that MIPs are getting is equal to the total amount that they are getting from the gaining from the MVNOs. So this way, like this MILPs has been formed. So this is the how we are basically solve this using a heuristic, as because an NP hard problem due to the combinatorial nature between the resource flow of the UEs to MIPs. So we have solved it using two stages. Using this bipartite graph, we see that the MIPs and MVNOs are initially sharing their resources, and once this upper tier resource sharing has been done, then we start doing the lower tier resource sharing. So, there is one assumption that we have taken, like without loss of any generality, that initially, like every time a new generation of communication upgradation happens, so the auctioning of the network spectrum happens. So basically, MVNO initially buys the infrastructure from the MIPs first, depending on some of the previous estimation of the users, and then MVNO generally sells its resources to the users. So depending on this assumption, we have created this. So initially, the upper tier matching will be done between the MIPs and MVNOs, and then the MVNOs and the UEs will be exchanging the resources depending on the heuristic. So here we have used very conventional the matching game theory. So here the two-tier matching game theory. So the upper tier first, like where the MVNOs and MIPs are playing are participating in it. So the ranking of the MIPs are done initially, obviously, which has been done by the MVNOs depending on the price that has been offered by them. So obviously, MVNOs are more likely to select the MIPs offering the least price or the lowest price for a particular service. And here we have considered that the demand of a particular MVNO that is being associated with the price offered to the MIPs, that the MVNOs actually are demanding some maintenance cost for the infrastructure that they are taking from the MIPs. So obviously, with the like if the MVNOs are asking for a particular price range, or maybe much higher price range for a particular resource, so in that case, MVNOs may demand that the service or the frequency of the service of those resources from the MIPs be much higher. So this way, just one example is given, like if the demand associated with a particular slice is like this. So 2468 are the unit of a particular resource. So if uh, the the price is increasing with per unit, so the associated demand will also increase. So means like for a single resource, if the MVNO is demanding or paying $8. So means it is expecting 4 times or four number of times of servicing of the particular resources. That means maybe that can be an installation tower or a base station tower or maybe a server that has been installed. So similarly, the lower tier matching with
Deborsi, you have
the
5 minutes to finish, then we'll
will
get into the
quickly show some
discussion.
of the results then. So the lower tier matching has been done between the UEs and the MVNOs. Similarly, the preference profile has been made between the UEs who ranks the MVNOs depending on the price range, and MVNOs are ranked the UEs depending on the price the UEs are offering or paying to the MVNOs. So these are the assumptions that I've already told that regarding the prediction that initially will be doing the purchasing for the resources MVNO does from the MIPs, and then the selling from the MVNOs will do the UEs. So this is the heuristics that has been shown here. So we have performed the upper tier matching first and then the lower tier matching, and I quickly show some of the results that we have achieved. So basically, our objective was to show that how the MIPs are gaining the revenue with respect to the existing state-of-the-art techniques. So we see that the upper tier matching or only auction model or random allocation, we are receiving much better revenue, the MIP's perspective. Also, we'll get more number of UEs are getting allocated to the MVNOs. Means the MVNOs are uh, not staying there idle. Most of the MVNOs are getting the UEs and the UEs perspective as well. So the price paid by the UEs are being minimized in our model, and also we are achieving the better SINR, almost 10 to 20% improvement we are achieving, and also like the MVNO selection criteria. So we are seeing that some of the MVNOs are becoming most preferred and some of the MVNOs are becoming less preferred. So this is obvious, right? So in the real life scenario, we see that whenever an MVNO is providing better services in low cost, suddenly we see that the number of users are shifted to that MVNOs. Like that happened when initially Reliance Jio launched in India. So the profit margin, we see a healthy profit margin for the MVNOs as well in our proposed approach. So to conclude is that our heuristics is basically provide a very better results apart from the existing state of the art techniques, and we include both the upper and lower tier matching that actually helps the involvement of all the UEs, MVNOs, and MIPs. And what we are currently looking is that so some of the remotely connected areas where there is no such involvement of the MVNOs and MIPs due to the poor profitable business. So now we are trying to develop certain models that can encourage them to come and deploy their infrastructure in those domains, so that those people residing in those areas can also enjoy the services like 5G and 6G. So the future would be a little bit of AI enabled. So as because AI is coming inside it, so we are expecting more flexibility and programmability inside the softwarized network slicing with the help of AI within it. So these are our references, and these two papers are currently under review. And one of the technical standard preparation is also going on with the TSDSI out of this book. And thank you very much, and for any further discussion. Yeah, thank you.
Yeah, thank you, Deborsi. Alex and Mehmet, do you have any thoughts on this contribution? If you're still there.
Well, what is the view of the authors on standardization? They have like vision for near-term ideas that can be put forward.
So Deborsi, can you answer that? What exactly?
So,
I mean, you have seen all the presentation today and the way we're taking the next step. How do you think this applies to either Open RAN activities or 6G? I know you're coming up with a model that could be applied. I can see the usefulness, of applicability of this model from the research aspect, but how do you think, what aspects of it can potentially be standardized?
So currently, as because this model is very basic prototype, and this is purely on the simulation perspective, there is no hardware deployment. But what we are looking for is that mostly uh, the virtualized brand resources that are being deployed, and those are being used by the network operators or the big telco players uh, to exchange or in the terms of the way they are building their service level agreements, so that we can some way somehow reduce the cost of the resources, so that ultimately the end users can make some benefit out of it. So I need to look into that, in which perspective the standardization may take this thing, and also like if any suggestions from the panel is there, then it will be helpful for us.
Deborsi, you can also standardize the framework. You don't have to kind of have it all worked out. Sometimes it's beneficial to go top down, because you already are deep in the details, but it would be nice to now, looking back, knowing your experience, having your experience, to standardize on the framework, the architectural, create an architectural standard that then will then pan out into implementation
Yeah.
standard.
I can
Yeah,
see, I mean, I'm glad to see that you're bringing some interesting economics aspect, which we all always get broiled into technology aspect, which is fine. We're making a linkage between services and slicing, and how to optimize the deployment of the slices based on the type of service MVNOs provide with respect to cost savings. That's a very interesting aspect. We are lacking models like this. Maybe some of this work will provide some incentives for 5G deployment. Sometimes people are still looking for new ideas, how to make it cost effective.
Ashutosh, this
Yeah.
is I think we need to think about this a little bit more. The reason is, the slicing based on SDN. I mean, that's not a new thing, right? That's how the slicing is done, based on SDN NFV. But the optimization using economics may be something new, but we need to think about how we can couch that one into a standard. I need a little bit more time personally to
Yeah.
digest that one. And
No, I agree. Mehmet, I agree with you. I think it is not the aspect of integration of SDN and NFV with slicing.
yeah.
But I think one thing I found little interesting here, service, right? So
Yeah.
you're linking the service. Each service may have certain requirement in terms of latency, quality of service, etc. And then you are assigning a slice based on that requirement. And now, how do you optimize that aspect, right? I think that, Deborsi, did I understand that correctly? I think you're
yes,
making a
yes,
linkage there.
yes.
Yeah.
So that is the
Correct.
optimization aspect that Mehmet is hinting on, right? That's probably the right thing.
Mhm.
It is not the mechanism of setting up a slice using SDN and FB, rather linking the service with creation of slices and the methodology model that he has developed to make it optimized, right? I think that's what I
Correct.
think.
Correct.
So maybe again we can somehow find a task force and look into this more carefully, more.
Yeah, yeah. I took some notes. Deborsi, if you agree, this is going to be a little bit different task force. It is not how to create slice, but rather how to create slice efficiently based on service requirement. And you have come up with a model framework to help do that, right? I think that could be
Correct.
an interesting idea. And then if you have an extended white paper, we can discuss that in our next or one of the monthly meetings, and we can also publish it if you like to in Tech Focus. There's one way to publish it quickly, and also could be an asset for our Open RAN or 6G working group. Okay.
Right.
Sure.
Good
Thank
suggestion.
you. Thank you very much.
Thank you. Yeah, I'm glad to see something a little bit interesting, a different type. So